Hi, right. I want to talk about matrices, okay? Because matrices is something that comes up big time at university. I got a bit of a shock, to be honest, when I was at university. Even though I'd done matrices before, I just didn't really realise just how important they were, how often they come up. It's like, there's matrix algebra, what is that? And there's various other methods with matrices. It was all over the place, okay? So first of all, what is a matrix? It's basically a set of information, okay, just contains some information. So all of these are examples of matrices, and they just contain numbers. Like this one is 2, -1, 1, 3. Okay, this is 0, 4, 3. Now each of these values we call an element. Okay, and so a matrix is made up of elements, right? So there's 3 elements make up that matrix. There's 4 elements make up that matrix. There's 9 make up that matrix, and so on. Okay. So, I call that an element, okay? So, you could say it's a bank of elements showing information. Well, what sort of information, okay? Well, you've done vectors, okay? Now, you've written vectors using column vector notation like this, okay? That is a simple example of a matrix, okay? The vector 4, 5, we also call that a matrix. It gives us information, and in coordinate geometry terms, that information could be a coordinate vector point, okay, or the coordinate point 4, 5. Now, if I take a few matrices and put them together, or a few vectors and put them together like this, okay, I've just written the vectors 4, 5, 4, 7, 1, 3, all together like that. And all I'm going to do is I'm going to just rub out those brackets like this, okay, and that is one matrix, okay. So, in terms of vectors, a matrix is a way of simplifying a string of vectors, okay? So take this one. This could be the vector 2, 1, 4, 3, 5, 6, 9, 10, all put together. This could be the vector 4, 0, 0, 0, 5, 0, 0, 0, 3, all put together, okay? And matrices are linked to coordinate geometry, and because they're linked to coordinate geometry, they're linked to algebra, okay? Because any algebraic equation you can plot or draw as a graph, can't you, okay? And so if you can have a matrix that represents anything on a coordinate geometry grid, you can also relate it to algebra. So that's why matrices are just all over the place at university, suddenly, okay, because they become, I'm not going to say easy, but a method that's used to help solve certain problems, okay. Simultaneous equations can be solved using matrices, and I'm going to try and give an example of how that works at some point, okay. But that's just a brief introduction about why matrices are useful. Okay, let's talk about some key terms of matrices. Okay, so I mentioned elements. Each one of these is an element. Okay, we talk about the size of a matrix. Okay, by how many rows and how many columns it's got. Okay, so this matrix here, for example, has got 2 rows and it's got 2 columns. Okay, so you've got 1 row, 2 row, 1 column, 2 columns. Okay, we call that a 2 by 2 matrix. Okay, this matrix here has only got 1 row and 4 columns. Okay, make sense? Okay, so 1 row only, but 4 columns. 1, 2, 3, 4. Remember, a row goes across and a column goes downwards. Okay, the way I remember that when I was at school, year 7, year 8, or whatever, was the columns are things that hold buildings together. Okay, a bit silly, I know, but there you go. Okay, this here is a 1 by 1 matrix because it's just got 1 row, 1 column. Okay, this matrix here, it's got 2 rows. Okay, and it's got 1, 2, 3, 4 columns. Okay, this one here is a 3 by 3. Okay, this one here has got 2 rows and 3 columns. Okay, so we sometimes talk about the size of a matrix as sometimes we say an m by n matrix, where m and n represent the number of rows and number of columns. Okay. That doesn't become too important, really, in the grand scheme of things, but you just need to be aware of that. Okay. Now I'm going to talk about how to add and subtract matrices. Okay, because that's fairly simple. Okay. It works in the same way as adding and subtracting vectors. Okay. I'll just show you exactly how it works. So I'm going to keep that one there. Okay. And what I'm going to do is I'm going to show you how to add matrices together. Okay. So this matrix, matrix 2, -1, 1, 3, okay, I'm going to add that to another matrix. I'm going to add it to 0, 7, 4, 5, okay. What do you think we do? all we do is we add the corresponding elements together. All right, so 2 corresponds to 0, okay, so that's going to give me 2. -1 corresponds to 4, so -1 plus 4 is 3. 1 plus 7 is 8. 3 plus 5 is also 8, and done. Okay, that's it. Okay, I've added those two together. Fairly simple, isn't it? Subtraction works in exactly the same way. Okay, so I'm not going to give you an example, but if we did that, subtract that, you just do that, subtract that, subtract that, and so on. Okay, so it's quite simple. Now, question I've got for you is this. Okay, I'm going to start with the same matrix. Okay, and I'm going to ask you this: can I add these two matrices together? Can I add those two matrices together? The answer is no. No, because the way matrix addition and subtraction works is you need to have corresponding elements in place. So you've got to have 2, right, and 2, -1 and 3. What goes with the 4? Nothing. I mean, literally nothing. You know, it's not 0. There's a difference between 0 and nothing. 0 is a numerical value. It's a number. Nothing isn't even a number. There's nothing there, so you can't do it. Okay. So what I mentioned before about sizes of matrices, that's quite important. Okay. So you can only add and subtract matrices that are the same size. Okay. If I turn this into the same size matrix as that, okay, let's just put in some numbers there. Okay. Now we can do it. We just do that plus that, 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 and so on. Okay. And we know the matrix will end up being of the same size. So that's rather simple. Okay. It's quite straightforward. Okay. So that's matrix addition and subtraction. What about multiplication? That's the first time I've laughed for a good few days. Maths has the ability to just make me laugh, just spontaneously, I don't know why. Okay. But matrix multiplication, what was that laugh for? Okay. It's not as straightforward as you might think. Okay. Let me just give you an example of how to do it. I'm going to use this matrix here. Okay. I'm going to make the numbers really simple. Okay. I'm going to multiply matrices of the same size. Now you might ask, do you have to have matrices of the same size? No. But there are certain matrices you can't multiply together. I'll show you those examples soon. Okay. So what we've got is, let me just write down, we've got a 2 by 2 matrix and another 2 by 2 matrix. Okay. Incidentally, these are what we call square matrices. When you've got the same number of columns as rows, that's a square matrix. Those are the most common form of matrix. You'll see why later on in the videos. Okay. How does matrix multiplication work? It is complicated when you start doing it, but once you've been used to it, it's kind of a method you get used to. Okay. But there's no proof of this. It's just kind of, it is what it is. Okay. So well, here's the method. Okay. What you do is you start with the first row of the first matrix, okay, and then you start with the first column of the second matrix, okay, and what you need to do is you need to multiply 4 by 2, let's write down what that is, 8, and 1 by 1, which is 1, and add them together, okay. That gives us the first element that goes in our answer there. Our first element is 9. Let me just run through that one more time, okay? You start with the first row, the first matrix, and the first column of the second matrix, okay? And what you do is you do 4 times 2 and 1 times 1, okay? Add them together, so 8 plus 1 is 9. It goes there, okay? What happens after that, okay? What you then do is you stay with that first row of the matrix and you go on to the second column of this matrix, okay? And you do the same again, and our answer will end up there. So you do 4 times 0, I'll write the answer here, which is 0, and you do 1 times 5, which gives you 5. Okay, 0 plus 5 is 5, and our answer goes by there. Okay. Then what happens is you continue until you run out of columns. Okay. So the method is you begin with the first row of the first matrix, and you multiply that row by all the columns in order of the second matrix until you run out of columns. When you run out of columns, okay, you then begin with the second row of this matrix and start all over again. That is, you take the first column and you do the multiplication, then the second column, and keep on going until you're finished. And then when you've run out of rows, that's it, you're done. And that's kind of a method for every single matrix multiplication question, okay? So let's just do that. So 2 times 2 is 4, and then you've got 3 times 1 is 3, 4 plus 3 is 7. The answer goes in there, okay? And then, as I said, we go on to the next column, and then we do 2 times 0, which is 0, and 3 times 5, which is 15, and the answer is 15. And so we get the answer 9, 5, 7, 15. Okay, and that is it. Okay, that is how matrix multiplication works. There'll be a few more examples, but before we go on to a different sort of example, let's see what happens when you multiply them the other way around. So let me just get rid of this. Okay, and so that times that equals that. Let's just put the matrices the other way around. 2, 0, 1, 5. And then 4, 1, 2, 3. Maybe pause the video and try and work out what the answer will be. It will not be the same. Okay. Did you do that? All right, so let's go then. So, look, remember the method? So we're going to start with this first row, and we're going to do that times that and that. So 2 times 4 is 8, plus 0 times 2 is still 8. Answer goes there. And then we go into the next column. 2 times 1 is 2, 0 times 3 is 0, so it's 2. Okay, you see how that worked? Right, next, I'm going to move on to this final row. 1 times 4 is 4, 5 times 2 is 10, so 10 plus 4 is 14. And then 1 times 1 is 1, 5 times 2 is 15, 15 plus 1 is 16. Right, can you notice you get a completely different answer, okay? So what that means is, this is an important rule, when you've got two matrices, A and B, the order doesn't matter. So matrix A multiplied by matrix B is not, so I'll put a not equal to that, not the same as matrix B times matrix A. Okay. Quite an important result there. Okay. Now, as you can see here, I've multiplied a square matrix by another square matrix. Remember I said a square matrix is when the same got the same number of rows as columns, okay? You can always multiply a square matrix by another square matrix, okay? However, what happens if you don't have square matrices? Can you multiply those together? Well, let's just take a look at that, shall we? I hope you made a note of that, so I'm rubbing it off. Now, see, gone. Ta-da, disappeared. Right. So, let's just take a look at another example, shall we? So, I'm just going to make this up. So, 2, 0, 1, 5, 3, 2, 1, 9. Okay, let's multiply. Let's try and multiply that by. What am I going to do here? I'll tell you what. Let's multiply it by. Let's try this. Okay. Let's try this and see what happens. Okay, let's try this and see what happens. Okay. Can you give me reasons to why you can't multiply those matrices together? Yeah? Because look, what you can do is you can start with the first row, and then you can start with the first column. You need to have the same number of elements in that row as in this column, because you can't do it. Because you're going to do 2 times 4, 1 times 0, you need to do 3 times that and 1 times that. Because there's nothing there, you can't do it. Okay, you can't do it. Okay, that can't be done. Okay, so what we're going to do instead is we're going to make it a matrix that can actually be done. So you should be able to multiply it by a matrix that's got 4 rows. Okay, so let's just make it 4 rows. 0, 1, 1, 2. There. I can multiply it by that. That could do. I can even multiply it by this. That will also do. I can even multiply it by. Let's just put a couple of negative numbers in there, shall we? Just for yeah. So what I've done is I've created. I start off with a 2 by 4 matrix, and now I've created a 4 by 3 matrix. Okay, and I can multiply those together. Should we talk through how that's done? Yep. Why not? Absolutely. Okay. So we take the first row of that matrix and we're going to multiply it by the first column of that matrix, okay, and see what happens. So you'll get 2, 1, 3, 2. So add those, if you want to make a note of it. So you have 2 plus 1, which is 3, plus 3, which is 6, plus 2, which is 8. So the answer is 8, okay. Right, next, okay, we're going to move on to the next column, okay. So this time we're going to multiply that by that, so it's going to be 4 plus 7, which is 11, plus 15, which is 26, plus 3, which is 29, okay? Your answers, by the way, always get written in the first row. So think of it, the first matrix, you're looking at the row, and your answer will be elements in that row, okay? And then next, we look at the last column, which is that, okay? So we have -2 plus that, so it's -7 plus that's -4 plus that -2, okay? And that's the first row done. Okay. Remember what happens next? When you've run out of columns, you then go on to the next row, okay? You can tell how many of these we're going to do because that's our last row, isn't it? Now, because that's our last row, our answers are going to go here. So can you see the size of the matrix we're going to end up with? Okay, is that right? Did I not write down the last answer or something? Because I've only written down 3 elements there. Check the last one. -2, -7, -4, -2. Yeah. What have I done? What have I done? You probably spotted what I've done. Oh no, it's fine. I thought I was going mad. Right, I raised the last 30 seconds. Gone. Okay. I thought I was going mad. I was full there. Yeah, I've only got 3 columns, haven't I? Yeah, so no one track. 3 columns. You see how confusing this gets sometimes? It confuses me. And this is, yeah, anyway, never mind. Right, so look, this is going to be our final row. So what that means is I can shut the matrix off there, which is not a mathematical term. But what I mean is I know that's going to be the size of the matrix I'm going to end up with, okay? Because once I'm done with that row, there's going to be no more, okay? I thought I was going mad. Anyway, there we go. So we're going to multiply this row by this column, okay? So that's 0, and then 5, 7, plus 18, 25, okay? And then here, we've got 0, that's 35, 10, 45 plus 27, 72. Yeah? If I make a mistake, just shout out at the screen, okay? I can't hear you, I know, but if it makes you feel better, okay? That's a pain doing this in class sometimes. You've got students who are just so fast at multiplying numbers together. You know, I'm not quick, to be honest. I'm fairly slow at multiplying numbers together. And people are like calling out numbers. You know, and it's worse when you've got a class and they're calling out different numbers. It's like, you ever try doing simple multiplication or adding together and people just calling out random numbers? It's like that sometimes. So I usually say, do it in your heads, and, you know, and then we'll look at it. Okay, let's do the last one. So that's 0. Isn't it nice when you've got zeros? Always nice when you've got zeros. It makes it easier. That's -25, -23, plus 18. 18 subtract 23, -5, yeah. And that's it, and that's our answer. Okay. Can you just notice what size matrix we've ended up with? We ended up with a 2 by 3 matrix. Okay. Now let me show you a rather handy hint for you to maybe just note down so you can tell whether matrices can be multiplied. Okay. When you write down the size of a matrix like this, 2 times 4, 4 times 3, as long as that number there is the same as that number there, you can multiply the matrices together. Why do you think that works? It's because that number there, you see, represents the number of columns, okay? And that number there represents the number of rows. So you can just see, you've got that there representing the 4 columns, and then you've got that there representing the 4 rows. So as long as those 2 numbers are the same, you can multiply them together. Okay? Maybe just try it with a few random matrices yourself. You just draw them out, okay? And just try and multiply them together, okay? And what answer do we get? Notice we get a 2 by 3, okay? Which is that and that, okay? That's always going to work as well, okay? So that number there, representing the rows of the first matrix, that number there representing the columns of the second matrix, that is the size of the matrix you'll end up with, okay? So as a generalization, when you've got an M by, let's call it a P matrix, okay, when you multiply that by a P by R matrix, okay, as long as that is the same as that, which is why I've chosen letter P, okay, then you can do it. And that will always result in an M by R matrix. That's just a generalization, okay. So when you've got an M by P matrix multiplied by P by R matrix, you can always then determine what the size of the matrix will be by looking at that, because it's an M by R. Remember the previous point we made? That matrix AB is not the same as matrix BA. Excellent way of just demonstrating that as well. If you swap these around, of course, you can't multiply a P by M and an R by P. Assume that M and R are different numbers, okay? If I swap those around, okay, you can't multiply those matrices together. It cannot be done. Okay. Should we do another example? Yeah, why not? Let's do another example. We won't do a race because I'm slow with these. And can we just say you won? I'm just so slow with these. You know, I'm actually pretty slow. But you know, slow is not that important, really, is it? Okay, in terms of mathematics, as long as you understand it. Okay, let's just put in some random numbers here. Zeros, lovely zeros. Who doesn't like zeros? Okay, 1, 1. So I've chosen a square matrix. Reason is these are the ones that most often come up. Okay, the vast majority of the time, I'm talking about 99% of the time, maybe. They're square matrices. Okay, that's a bit of a high number, really, 99% of the time. But I kind of stand by that. It's a very high percentage chance of them coming up anyway. So let's put another 0 there. Let's put a 1 there. 3. Zeros and 1s are always lovely numbers to have in a matrix. Okay, 4, 7. I know 2. I don't know. Did you want a race? I mentioned race now. You're probably disappointed. I don't know. Just better, I'm very slow. Okay. Anyway, those are the matrices. Okay. Maybe just before you start, you're probably thinking, right, go. I hope you haven't paused the video. Okay. Because otherwise it's messed up, isn't it? What size matrix do we end up with? Well, as a generalisation, a 3 by 3 matrix times a 3 by 3 will end up with a 3 by 3. Any square matrix times by another square matrix, you get exactly the same size matrix. Okay, I'm sure you appreciate the reasons why. Okay. Well, if you want to race, fine. Just bear in mind, I'm not going to do the row column thing. Okay, I'm just going to look at the numbers and just, I might make some notes here, I don't know. But just, yeah, so anyway, well, let's just do this. But you win, okay? I can't see that happening. All right, if you want, let's just go, all right? I know you finished. You've probably finished and had a cup of tea and biscuits, gone for a run around the park, whatever, okay? Yeah, fine. Then I get right. I could have made a mistake, so I was kind of going quickly as well. Yes, that was me going quickly. Okay. Yeah. But anyway, so I didn't talk you through it, did I? So maybe I'll just talk you through it. Okay. I don't know how you're feeling about these already. But now's the time to put the row and column thing in. Did you see me make a mistake earlier? And rub it out again. That's why there's a bit of a mess there. Okay. Anyway, so right, so you got 0. I told you the zeros are nice. And you got 1 plus 9, which is 10. There we go. And then move on to the next one. Okay, which is there. And so we've got 6, 7. It's there. Okay. And then we go on to the next one. My fingers do get dirty doing this, by the way, but never mind. 8 plus 7, which is 15, plus 6, which is 21. There we go. Ooh, got the first ones right. Okay. And then we start with the next row, of course. There we go. And then here it gets rather messy, doesn't it? So that's going to be 0, that's 5, that's 12, that's 17, there we go. See, my mistake was, I don't know why I did this, I started with that, but I quickly knew I went wrong because I did that again. I thought that can't be right. So 0, that's 5, that's 0, so there we go, 5, and then this is a high number, isn't it? 43. Let's see what's going on there. So you got 0, so that's why it's 35 plus 8, isn't it? It's 43. There we go. Good. And then last one. Okay, there and there. Okay, so 0, 1 plus 3, it's 4. Okay, and then there we go. That's 9, 10. There we go. And last one. Okay, 12 plus 7, 19. Plus 2 is 21. There we go. Great. I'll give myself a tick because I'm quite pleased with myself. Okay, yeah. It's just very simple to make a mistake. So. Anyway, that's it. It's matrix multiplication. Okay, well done. Treat yourself to whatever you think should be treated to. I don't know what that is. Okay, more maths maybe. I don't know. But yeah, before we go to the next video, this has probably been quite a long one, isn't it? There's no matrix division. Okay, you might have been thinking, right, let's do division next. No, there's no matrix division. No such thing. Okay, there's inverse matrices. Okay, that's the alternative to division, but there's no matrix division. Okay. Right, that's it. Hope you enjoyed the short-ish introduction to matrices.